Hello, welcome to the Self-Learning Podcast by Dr. Sushma Singh. Let us start discussion on Unit 18, Statistical Inference Test of Hypothesis. And our topic is Tests of Significance. First is chi-square test. Chi-square is probably the most commonly used of all non-parametric tests. It is applicable when data are nominal and grouped in categories. You can examine the difference between the observed and the expected frequencies. The calculated value of chi-square is compared with the table value of chi-square for given degree of freedom at a certain specified level of significance. For example, 5%. If the calculated value of chi-square is higher than the table value of chi-square, then the difference between the theory and observation is considered to be significant. On the other hand, if the calculated value of chi-square is lower than the table value of chi-square, then the difference between the theory and observation is considered to be non-significant. As mentioned above, while comparing the calculated value of chi-square with the table value of chi-square, one has to determine the degree of freedom. Degree of freedom is the number of classes to which the values can be allocated at will or arbitrarily without defying the limits or restrictions. For instance, if one has to choose 4 numbers whose sum is 100, the freedom of choice exists only for selecting 3 numbers, and the fourth is selected automatically. If, for example, the first 3 numbers are 14, 26, 32, then the fourth is fixed and must be 28. That is 100 minus 14 plus 26 plus 32. In this case, the degree of freedom is 3. Chi-square is used for a variety of purposes. Also, there are numerous tests that are close to chi-square. Hence, the test of goodness of fit and the test of homogeneity or association are presented. Now the next topic is the test of goodness of fit. We often want to know whether the observed frequencies are in agreement with the probability or expected theoretical distribution or not. The following steps may be followed. Define null and alternative hypotheses. Decide probability level. Estimate the expected frequency E for each category based on the theory and or probability. Calculate chi-square. Determine the degree of freedom. Compare the observed chi-square with the tabulated chi-square. Accept or reject the null hypothesis. Now the next one is a test of association or homogeneity. This type of chi-square is used for 2 purposes. The first purpose is to examine whether or not the 2 or more attributes are associated. The second purpose is to determine whether 2 samples are drawn from the same population or not. In the former case, the data is based on 1 sample, whereas in the latter, there are 2 or more samples. Chi-square, a non-parametric test, is a rough estimate of confidence. It accepts weaker, less accurate data as input than the parametric test. Like t-test and the analysis of variance, and therefore has less status in the pantheon of statistical tests. Nonetheless, its limitations are also its strength, because chi-square is more forbearing in the data it will accept. It can be used in a wide variety of researches. The steps in the chi-square method for the test of homogeneity remain the same as that of the test of goodness of fit, except that in step 3, the expected frequencies are calculated for each cell as illustrated. Now the next test is student's t-test. Student's t-test is a parametric test most suitable for small sample. It is probably the most widely used statistical test and certainly the most widely known. It is simple, straightforward, easy to use, and adaptable to a broad range of situations. As a statistical toolbox should ever be without it. Student developed the statistical method to solve problems stemming from his employment in the brewery, like chi-square. The following step may be followed for the use of the student's t-test. Define null and alternative hypotheses. Decide probability level. Calculate the value of t using appropriate formula. Determine the degree of freedom. Compare the observed chi-square with the tabulated chi-square. Accept or reject the null hypothesis. Student's test is applied in different conditions, such as to test the significance of the mean of a random sample, to test the difference between the means of the two independent samples, to test the difference between the means of the two dependent samples, to test the significance of the correlation coefficient. Let us discuss each of the above conditions one by one. The first is to test the significance of the mean of a random sample. This test is used when the researcher is interested in examining whether the mean of a sample from the normal population deviates significantly from the hypothetical population mean. The second one is to test the difference between the means of the two independent samples. This test is used when the researcher is interested in examining whether the respective means of two independent samples differ significantly from each other. Now the next is to test the difference between the means of two dependent samples. This test is used when the researcher is interested in examining whether the mean of two dependent samples differ significantly from each other. And the next is to test the significance of correlation coefficient. Whether a coefficient of correlation is significant or not may be tested using the formula. Now let us conclude the unit. This unit has provided you with a range of ways in draw inferences. There are a good number of examples given for you to try and prepare your own examples. The exercises of working with as many as possible examples would help you to master the skills of testing hypotheses and estimating unknown parameters of the population. You need to keep in mind that no matter what design you use to test a hypothesis, you would reach only approximations in terms of probability. The testing of a hypothesis prepares you the ground for generating further hypotheses, and in this matter the scientific knowledge progress. Initial approximations put on firm basis the original hypothesis, and from this you can further deduce other hypotheses. If you are able to establish links between the propositions, you would have generated scientific knowledge. Now let us wind up the session, and we have come to the end of the unit. Thank you very much for engaging yourself with the Self-Learning Podcast.